You know, usually when we talk about a business succeeding or failing, there's this expectation of like clinical precision.
Oh, absolutely. I mean, we love financial statements because they're comforting, right?
Right, exactly. You look at a balance sheet and the revenues are up, the costs are down, the margins look healthy.
Yeah, everything is neatly categorized in these little columns and rows. It gives the illusion of total control.
It really does. And the analyst just points to the spreadsheet and says, there it is. That's why they're winning. But the balance sheet is just a trailing indicator, isn't it?
100%. By the time a number actually hits that page, the actual war has already been won or lost.
Yeah, because when you step out of the boardroom and into the physical reality of how a product gets made, moved, and delivered.
The muddy waters.
Right. When you step into the world of global supply chains, that financial x-ray machine is just totally useless. We're suddenly looking at an operational landscape that is incredibly muddy, totally decentralized, and frankly, highly vulnerable.
It is the absolute definition of diagnostic muddy waters.
I know.
I mean, the physical mechanisms that make or break a modern company are often entirely invisible to the end consumer.
And to the company itself sometimes.
Terrifyingly so, yeah. A CEO might know their quarterly revenue to the penny, but they might have absolutely no idea that, say, a Tier 3 supplier in another hemisphere just went bankrupt.
Wow.
And that means in exactly 6 weeks, their entire flagship product line is just going to grind to a halt.
And that's exactly the mystery we're unpacking today for you, the listener. Welcome to this custom-tailored deep dive. We're going to act as your personal pedagogical coaches as we explore the dense, highly strategic, and just unseen architecture of global commerce.
And we have some phenomenal source material today.
We really do. We're drawing our insights from a comprehensive text called Strategic Supply Chain Management by Syed Abdul Rehman and Zhang Yu, published by Springer.
It acts as a master map, really.
Yeah, our goal here is to shortcut your way to being well-informed on this topic. So whether you're prepping for a massive operational pivot or you're just insanely curious about how the goods you buy actually reach your door, we're going to extract the most important technical nuances from this text.
Because we won't just learn what a supply chain is, but why specific strategic designs succeed while others completely collapse.
So let's jump right into Chapter 1, the introduction. The big idea here, essentially, is that supply chain management, or SCM, is the seamless integration of all partners.
Right, from the raw material suppliers all the way to the end customers.
Exactly. Designed to deliver the right product to the right place at the right time, minimizing costs while meeting strict service levels.
Right product, right place, right time. I mean, it sounds like a simple corporate slogan.
Yeah, it does.
But the execution of that is where the immense friction of SCM actually lives. Because to achieve that, you have to coordinate hundreds of independent corporate entities as if they were a single organism.
Which begs the obvious historical question, right? If coordination is the hardest part, why don't companies just own the whole thing?
Vertical integration.
Right, vertical integration. Like Henry Ford used to literally own the rubber plantations in Brazil for his tires, the iron mines for steel, the ships, the factories.
He didn't have to coordinate with partners. He just issued orders to his own employees.
Exactly. But the text makes it very clear that vertical integration has largely failed in the modern era. Why is that?
Well, it fundamentally comes down to capital allocation and, the sheer complexity of modern consumer demands.
Okay, let's unpack this.
So, as global markets matured, consumers demanded infinitely more variety, faster innovation cycles, lower prices, and no single corporation, no matter how massive, could maintain world-class expertise in every single vertical.
Because if you own the rubber plantation, you suddenly have to manage, agricultural yield, soil degradation, foreign labor relations.
That requires a massive amount of capital and executive attention.
It distracts from what you're actually good at.
Precisely. It distracts from your core competency. If your main thing is designing the most advanced electric vehicle software, every dollar an hour you spend figuring out how to optimally run a tire factory
is time your competitor is spending on better software.
Exactly. You dilute your strategic advantage. Trying to be a jack of all trades today is basically a mathematical death sentence.
So the realization that vertical integration is just too heavy and slow gave rise to strategic outsourcing. Companies shed their factories, shed their fleets, and began relying heavily on 3PLs, third-party logistics, and 4PLs.
Right, fourth-party logistics providers.
Yeah.
These are highly specialized firms whose sole core competency is dedicated to moving and storing goods efficiently.
Right.
So a 3PL might manage your warehousing and trucking. A 4PL goes a step further and actually manages the 3PLs. They act as the strategic architect.
But I mean, shedding that physical ownership creates a massive new vulnerability, doesn't it?
Oh, absolutely.
Because you no longer own the factory or the trucks. You can't just walk down to the production floor and tell the foreman to speed up based on what sold yesterday.
No, you have to communicate those demand signals across corporate boundaries, often across oceans.
To companies that have their own financial incentives.
Right.
And that brings us to what feels like the central villain of this whole thing, the bullwhip effect.
The bullwhip effect is arguably the single most critical concept to grasp if you want to understand why supply chains fail.
Okay, let me try an analogy here to visualize this. Imagine you're driving on a busy highway.
Okay.
Traffic is moving smoothly. Suddenly, one person at the front taps their brakes because they saw a piece of debris.
Right.
The person behind them sees the brake lights, overreacts a tiny bit, and hits the brakes harder. The next person slams on theirs. By the time you get 3 miles back, traffic has come to a dead, screeching halt. That's the bullwhip effect, right?
Yeah, that is a perfect analogy. And to take it further, the guy at the back of the line isn't just stopping. He's turning his truck around and going home, deciding not to deliver the goods at all.
Wow.
That is lost revenue, wasted fuel, misallocated capital. In a supply chain, that initial tapping of the brakes is just a minor fluctuation in consumer demand at the retail level.
Like maybe a store sells 5 fewer units of a product this week than they expected.
Exactly.
But wait, how does 5 unsold units at a retail store turn into a catastrophic factory shutdown in Taiwan?
Well, the text details the specific operational mechanics that cause this distortion, and it usually stems from a profound lack of visibility. The first major culprit is order batching.
Right, because a retailer doesn't order one single item every time a customer buys one. The freight costs would bankrupt them.
Exactly. They wait until inventory drops to a certain level, and then they place a massive batch order, say 1,000 units, to get a bulk shipping rate.
Oh, I see.
Think about how that looks to the wholesaler sitting upstream. To them, it looks like there was absolutely zero consumer demand for 3 weeks, and then suddenly this massive explosive spike for 1,000 units on a random Tuesday.
So the wholesaler panics. They think, wow, this product is suddenly flying off the shelves. So they don't order 1,000 from the manufacturer. They order 1,500 just to be safe.
And build a buffer. Right.
Yeah.
And then the manufacturer sees an order for 1,500, assumes a massive global trend is emerging, and orders enough raw material for 2,000 units.
The distortion amplifies at every node.
At every single node.
Yeah.
But it's not just batching. The authors also point to price variations as a massive driver of this artificial demand.
Yeah. Temporary discounts create havoc. Like, if a manufacturer offers a 10% discount for the month of March, buyers engage in forward buying.
Exactly. They buy significantly more inventory than their actual consumer demand requires, simply to lock in the lower price.
Which artificially inflates the demand signal. So the manufacturer's factory runs 24/7 to meet this huge March order, paying overtime.
Stressing the machinery.
And then in April, orders drop to absolutely zero because the buyers are just sitting on the cheap inventory they hoarded.
Right. You get these extreme peaks and valleys in production, which is the most expensive possible way to run a factory.
Right.
But there's a third major driver of the bullwhip effect that the text highlights, and it's something we are all incredibly accustomed to as consumers: generous, free return policies.
It's fascinating because we treat free returns as a basic human right in e-commerce now. But how does my decision to return a sweater cause manufacturing chaos months before the sweater is even made?
Because a sale isn't truly a finalized demand signal until the return window officially closes.
Oh, that makes sense.
If a retailer offers a 90-day, no-questions-asked return policy, they have to mathematically factor in a massive, unpredictable return rate. Consumers might buy 3 sizes of the same jacket, knowing they'll return 2.
So upstream, the manufacturer sees the order for 3 jackets and scales up production.
Exactly. And when those 2 jackets come back, they enter the reverse logistics pipeline, they eat up warehouse space, and they instantly kill the need for future production. It makes accurate forecasting nearly impossible.
And speaking of reverse logistics, the text highlights that supply chain management is not just a one-way street, right?
Not at all. Reverse logistics, the flow of goods from the customer back upstream for recycling, returns, repairs, is a massive, heavily constrained operational muscle. And it behaves entirely differently than forward logistics.
How so? Because in forward logistics, you have these neat, predictable pallets of identical goods leaving a factory.
Precisely. Forward logistics is highly standardized. Reverse logistics is pure chaos.
Yeah, I can imagine.
You are receiving individual, unboxed, potentially damaged items arriving randomly from thousands of different residential addresses. The labor required to inspect, grade, repackage, and digitally restock a returned item is exponentially higher than the labor required to ship it out in the first place.
Which means if you haven't engineered your network to handle that reverse flow, your entire system chokes.
Exactly.
So to recap the practical takeaways from Chapter 1, supply chains have to balance cost minimization with service level maximization. The bullwhip effect destroys upstream efficiency through poor communication and batching. And vertical integration is out. Strategic outsourcing is in.
That's the foundation, yes.
I want to throw a critical thinking challenge to you, the listener. Think of a recent product you returned. How many discrete steps and companies were involved in getting that item back to a warehouse or recycling center? And secondly, how might a company's generous free return policy unintentionally cause manufacturing chaos for its upstream suppliers?
It really reframes how you look at a simple return label, doesn't it?
It really does.
Yeah.
And understanding the sheer scope of this naturally leads us to the realization that managing it requires incredibly complex network designs. You can't avoid the bullwhip without the right architecture. Which brings us to Chapter 2. Key issues in logistics and supply chain. The big idea here is that in today's market, competition is no longer firm versus firm. It is supply chain versus supply chain.
Right. Making collaborative information sharing the ultimate competitive advantage.
So it's not simply brand X versus brand Y sitting on a shelf.
No, it's the entire ecosystem of brand X. Their raw material sourcing, shipping lanes, warehousing, IT warring against the ecosystem of brand Y.
Like Apple, Tim Cook didn't ascend to CEO simply because he was a product visionary. He ascended because he's arguably the greatest supply chain architect in history.
Exactly. He built a network so ruthlessly efficient that rival brands simply couldn't compete on margins or volume, even if they had a comparable product.
So how do you configure a network to achieve that? Supply chains aren't just straight lines. The text breaks down 3 primary models: disconnected networks, connected networks, and semi-overlapped networks.
Right. In a disconnected network, firms operate in their own silos. I buy from you, you ship it, the transaction ends. Minimal strategic interaction. It's slow and prone to massive bullwhip effects.
And a connected network?
That's where there is deliberate, synchronized flow, usually driven by a dominant focal company that mandates how the other nodes behave.
Okay, but what about the semi-overlap network, the N+1 layer model?
This is where reality lives for most complex industries. The text uses the high-tech industry as a prime example. In high-tech, you might be a computer manufacturer buying microchips from a Tier 1 supplier.
Okay.
But that exact same Tier 1 supplier is also selling those chips directly to your biggest competitor. And simultaneously, they might be selling standalone chips directly to the end consumer in a totally different market.
Wait, I have to push back here. If the goal is seamless integration and total visibility to kill the bullwhip effect, isn't a totally connected network always better? Shouldn't every node be transmitting data continuously?
It seems intuitive on paper, but if you try to fully connect every single node in a massive global network, 2 catastrophic things happen. First, you drown in data noise. The computational power and human attention required to parse millions of irrelevant data points from a supplier-side businesses will paralyze you.
Okay, and the second thing?
Corporate suicide. Information is leverage. If you demand that your Tier 1 supplier gives you unrestricted access to their internal systems, they are exposing their cost structures, their alternative revenue streams, their capacity limits.
Oh, I see. If I'm a giant retailer and I can see in your system that it only costs you $2 to manufacture the widget you sell me for $5.
You're going to squeeze their margins immediately.
Exactly. I'd squeeze it down to $2.10.
Precisely. Trust is the rarest commodity in a supply chain. Overlapped networks create immense complexity because every player is trying to optimize the network's efficiency while fiercely guarding their proprietary secrets. Therefore, reality dictates a semi-overlap space. You share only the data that is mutually beneficial.
But even sharing mutually beneficial data is incredibly hard. How does a company actually evolve from a disconnected silo to a collaborative network?
The text details Stevens' 4 phases of integration. Phase 1 is the baseline phase, just mapping what you actually have. It's astonishing how many multi-billion-dollar companies don't have a mapped understanding of their own Tier 2 or Tier 3 suppliers.
They know who they write the check to, but not who that guy writes a check to.
Exactly. Phase 2 is internal integration. Before you can talk to external partners, you have to get your own internal departments talking to each other.
Which is notoriously the graveyard for most corporate initiatives.
It is the hardest phase because different departments have conflicting KPIs. The purchasing department is bonused on buying raw materials cheaply, so they buy in massive, infrequent batches.
But manufacturing is bonused on smooth factory uptime, which needs a steady trickle of materials.
Right. They are structurally at war within the same company. Only when you master Phase 2 can you move to Phase 3, external integration, linking your systems with primary Tier 1 suppliers.
The Phase 4.
Advanced integration scheme. True. End-to-end synchronization across the entire semi-overlapped network.
And here's where it gets really interesting. The lifeblood of Phase 3 and Phase 4 is information sharing, specifically sharing ERP data enterprise resource planning.
Yes. This is the ultimate antidote to the bullwhip effect. If a manufacturer is granted access to the actual real-time point-of-sale data from the retailer's cash registers, they don't have to rely on distorted purchase orders.
They see the raw demand signal the exact second a consumer buys the product. The bullwhip loses its momentum.
Instantly, the guessing game is eliminated.
To recap the practical takeaways from this chapter, your true competitors are rival supply chains, not just rival brands. Information sharing is the only way to synchronize overlapping network nodes. And true integration moves in phases. You must master internal integration before attempting external integration.
Absolutely essential.
Critical thinking challenge for you. If your company relies on a semi-overlapped network, what specific data points must you share with a Tier 2 supplier to prevent bottlenecks? And why might a supplier be hesitant to fully integrate their ERP system with a major retailer?
Some great questions to ponder.
Which provides the perfect connective tissue to chapters 4 and 6, warehousing, storage, and design. Because once a company decides on its network configuration, it needs physical nodes to store and route its goods. The network map is useless without physical warehouses.
And warehousing is often totally misunderstood.
Right. The big idea here is that a warehouse is a highly engineered, dynamic node that dictates the physical flow of goods. Poor warehouse design fundamentally threatens the success of the entire supply chain.
It's not just a big empty building where you bolt some racks to the concrete.
Yeah, the old mental model is like a giant, high-stakes game of Tetris with moving parts. Just pack the boxes in until you run out of square footage.
Which is a disastrous way to design a facility. A modern warehouse is less like a storage unit and more like a high-speed sorting engine. You have to map specific constraints from the text.
Like what?
First, arrival and dispatch patterns. Are your trucks arriving continuously across a 24-hour period? Or do 50 trucks arrive simultaneously in a massive wave at 3 a.m.?
If they arrive at 3 a.m., a warehouse with only 5 loading docks is instantly paralyzed. The trucks sit idling, incurring fees.
Exactly. Then you have to design around vehicle types. Are the inbound trucks end loaders, where a forklift drives into the back from a raised dock? Or are they side load vehicles requiring massive ground-level yard space?
I can see how that destroys a capital investment. If I spend $20 million building a facility with 50 raised end-load docks and my 3PL provider suddenly switches to side-load trucks to save fuel my warehouse, is a massive bottleneck.
It happens more often than you'd think. Then consider unit loads. Are you storing unbroken pallets? Or is this a fulfillment center picking individual items for e-commerce?
The racking structures are fundamentally different for pallets versus piece picking.
And beyond storage, you have ancillary activities. You need dedicated space that generates zero revenue but is operationally mandatory.
Like battery charging stations for electric forklifts.
Right, requiring specific ventilation. Or quality control areas. And a massive dedicated area to process reverse logistics.
Returns. And if returns double, that reverse logistics area starts aggressively eating into your outbound storage space.
It creates an immediate physical choke point.
So the physical layout is dictated by operational behavior, but managing the movement inside requires perfection. The text outlines data capture and legality.
Yes, the physical movement of a box must be matched instantaneously by a digital update. Modern warehouses function via radio data communication. If a worker moves a pallet but forgets to scan it, that pallet is essentially lost.
The digital record in the WMS, the warehouse management system, diverges from physical reality.
And there are strict legal regulations regarding safety, resource utilization, and working conditions that dictate how fast those workers can even move.
So to recap, Warehouse design must start with data on vehicle types, unit loads, and dispatch patterns. Warehouses require dedicated space for ancillary operations. And real-time data transmission is mandatory for maintaining stock integrity.
It's a highly complex ecosystem.
Time for a critical thinking challenge. If a warehouse is designed perfectly for end-load vehicles, how does the sudden introduction of side-load vehicles disrupt the entire site layout? And how does the footprint of a warehouse change if reverse logistics double in volume?
It really makes you appreciate the engineering behind these buildings.
It does. And designing the physical space is only half the battle. You have to know exactly what is sitting on those pallet racks and why, which catapults us directly into the mathematics of Chapter 5, inventory management.
This is the intellectual core of supply chain profitability.
The big idea here. Effective inventory management requires distinguishing between dependent and independent demand and applying rigorous statistical models to prevent stockouts while minimizing holding costs.
You cannot manage dependent and independent demand the same way.
Okay, I need a clear distinction here. What's the practical difference?
Independent demand is generated entirely by the end customer. It's external. It's you, the consumer, deciding to buy a car today instead of tomorrow. You can forecast it, but it's inherently volatile.
Got it. Independent demand is the unpredictable human at the end of the chain.
But dependent demand is derived purely from that independent demand. It's internal. If the factory receives an order to build one car, that factory now has a strictly dependent demand for exactly 4 tires, 1 steering wheel, 1 engine block.
There's no forecasting needed for dependent demand. It's just a rigid mathematical recipe.
Precisely. But because a complex product might have tens of thousands of parts, you cannot treat all of your inventory equally. This leads to the ABC analysis.
So what does this all mean practically? It's like Pareto's principle applied to inventory, right? The 80-20 rule?
Yes, you rank every item based on its annual dollar usage and current value. A items are the vital few. Maybe 10% of your items, but 80% of your inventory value. They need tight control. C items are the trivial, many cheap, massive quantities. They need less control.
So if I'm manufacturing high-end racing bicycles, the custom carbon fiber frame is an A item. It's expensive, long lead time. My system needs to track that hourly. But the tiny plastic end caps for the handlebars, those are C items. They cost 2 cents. I just buy a massive bucket, stick it in the corner, and order another bucket when it looks half empty.
That is the exact strategic application. But there's a critical caveat. What if you have an item that has a very low annual dollar usage, technically a C item, but it is a critical dependency for your flagship product?
Oh, right. The classic scenario where a missing 10-cent rubber O-ring halts the production of a $100 million rocket.
Exactly. Operational reality dictates that criticality must override pure financial value. That 10-cent part must be managed with A-level rigor.
Wow. So even with a perfectly categorized inventory, how do you know exactly when to order more and exactly how much to order?
That's where the statistical models step in.
Yeah.
The text introduces the economic order quantity, the EOQ model, and the statistical reorder point, the ROP.
Okay, I want to push back here. Do we really need all this math if we have RFID tags? Radio frequency identification. If my computer constantly knows exactly what I have, doesn't the tech just solve the inventory problem?
This is a very common, very dangerous misconception. RFID is a brilliant tracking technology. It gives you near-perfect visibility. But visibility is not strategy.
What do you mean by that?
RFID tells you that you have exactly 100 carbon fiber frames left. But the mathematical models, like EOQ, tell you whether 100 is the right number to have in the first place.
Oh, I see.
EOQ balances the cost of holding inventory against the cost of ordering inventory.
So RFID automates the tracking, but the mathematical models automate the strategic decision-making. EOQ tells me how to drive the car.
Perfectly stated. The math calculates your optimal order size, and the ROP, the reorder point, dictates the exact moment you should pull the trigger on that order.
So for our practical recap, treat different inventory differently using the ABC matrix. Use MRP for dependent demand and statistical models for independent demand. And remember, RFID automates tracking, but mathematical models dictate strategy.
Spot on.
Critical thinking challenge. Using the ABC matrix, how would you classify an item that has low annual dollar usage but is a critical dependency for your flagship product? And when would a periodic review system be more beneficial than a continuous review system for a local retailer?
Essential questions for any inventory manager.
Which forms the connective tissue to Chapter 7, domestic and global logistics.
Mm.
Because once inventory leaves that meticulously managed warehouse, it enters the unpredictable real world.
It has to physically move.
Right. The big idea here. Logistics is the engine of commerce that creates time and place utility by navigating a complex matrix of transportation modes and legal structures.
Time and place utility. The text defines this clearly. Goods have zero value until they are delivered to the exact place they are needed, exactly when they are needed.
So a shipping container full of heavy winter coats sitting in a warehouse in Los Angeles in the middle of July has zero utility. It's actually a liability.
Exactly. But that exact same container arriving at a retail store in Chicago on the first snowy day in November has immense utility. Logistics is the engine that transforms the liability into an asset.
And moving things involves navigating legal forms of transportation. Let me try an analogy here. Choosing carriers is like choosing travel. A common carrier is like a public city bus. Publicly regulated rates, they have to take anyone who pays the fare.
Highly accurate framing.
A contract carrier is like a chartered bus. You negotiate a private contract, dictate the route, nobody else allowed on. And a private carrier is like owning your own car. You own the trucks, hire the drivers, take all the liability.
And the text expands on exempt carriers as well. Decided to invest in a private carrier fleet is a massive capital allocation decision. Most companies opt for contract carriers.
And within those legal wrappers, you have the modes of transport. Motor, rail, air, water, pipeline, and intermodal.
And every mode is a brutal strategic trade-off. Air freight is fast but exorbitant. Ocean freight is cheap but slow and vulnerable. Motor freight remains the backbone because it offers flexible door-to-door delivery.
And what's fascinating here is how architects use these modes to execute risk pooling.
Yes, risk pooling in warehouse locations mitigates demand uncertainty.
Like, if I sell umbrellas, I could build 50 small warehouses in every state. But if it doesn't rain in Texas, I have dead inventory.
But with risk pooling, you build one centralized warehouse in the middle of the country. You pool the statistical risk. If demand drops in Texas but spikes in New York, the central pool balances the volatility.
You save millions in holding costs. Alongside a discussion on transportation regulation versus deregulation, deregulation sparks massive innovation, right?
It does. Carriers can suddenly negotiate flexible pricing and evolve into true 3PL strategic partners.
So, practical recap for Chapter 7. Logistics exists solely to provide time and place utility. Choosing a carrier legally limits your liability and dictates costs. And risk pooling across multiple warehouse locations protects against regional demand shocks.
Exactly.
Critical thinking challenge. Under what circumstances would it make strategic sense to switch from a contract carrier to investing in a private carrier fleet? And how does transportation deregulation impact the strategic choices a 3PL provider can offer a client?
Great questions.
Which brings us to the connective tissue for Chapter 9. We've built the network, stocked the inventory, shipped the goods. But how do we know if any of this is actually working efficiently?
We need robust performance measurement.
The big idea. You cannot manage what you do not measure, but poorly designed metrics like an obsession with short-term cost reduction will ultimately destroy supply chain value.
The text outlines why we measure. Supporting decision-making, improving communication, providing feedback, and motivating behavior.
But the pitfalls. Having too much data, lacking detail. And the most dangerous one, measuring behavior instead of accomplishments.
Right. If you measure a purchasing manager's behavior, you look at their calendar, 50 meetings, 1,000 emails, you bonus them for being busy.
But if the factory is still shutting down because of cheap, defective parts, it doesn't matter how many emails they sent.
Exactly. You rewarded the illusion of work, not the accomplishment. To combat this, the text introduces the balanced scorecard for supply and purchasing.
Tracking non-financial measures alongside cost, like quality parts per million, defect rate, delivery time, and innovation.
Innovation is key.
But if our profit is up, why do we care about innovation measures? Profit is the ultimate scorecard, right?
If we connect this to the bigger picture, short-term profit is frequently a smokescreen. Let's say you incentivize purchasing purely on cost avoidance. They aggressively squeeze your suppliers for lower prices.
And my quarterly profit looks fantastic.
Yes, but you've squeezed their margins so thin they can't afford research and development. They stop innovating. 2 years later, your competitor supplier invents a fundamentally superior component.
And suddenly my product is obsolete.
Exactly. Today's lack of innovation is tomorrow's lost market share.
Practical recap. Do not confuse measuring behavior with measuring actual accomplishments. A measurement system must be directly associated with organizational goals, and use a balanced scorecard to track time, quality, and innovation alongside cost.
Perfect.
Critical thinking challenge. If you incentivize a purchasing manager strictly on cost avoidance, what negative downstream effects might they inadvertently cause? And how do you design a metric that accurately captures responsiveness to schedule changes?
Those will test your understanding.
And a mature measurement system naturally reveals inefficiencies that aren't just financial, but ecological and technological, which leads us to chapters 10 and 11, environmental issues and IT integration.
True supply chain maturity requires integrating advanced IT across 5 distinct phases, allowing firms to manage not just profits, but the triple bottom line.
What does green SCM actually mean practically? Just solar panels?
It's managing the economic, biophysical, and ethical impacts. Biophysical means managing pollution and the waste hierarchy. Ethical means ensuring you aren't funding child labor or unsafe conditions, 3 tiers down.
But a compliance officer can't fly to 10,000 subcontractor factories every month.
Which is why IT is inextricably linked. The text outlines the 5 phases of IT integration. Phase 1 is fundamentals basic internal automation. Phase 2 is cross-functional teams.
Phase 3 is the integrated enterprise, right? Efficiency across the whole firm on one system.
Yes. Phase 4 is the extended supply chain connecting externally to create market value. And Phase 5 is the ultimate goal, communities of supply chain.
It's like human evolution, starting as an isolated cell in Phase 1 and evolving into a massive interconnected nervous system in Phase 5.
And without EDI, WMS, and ERP systems, achieving Phase 5 or effectively monitoring the triple bottom line is completely impossible.
Technology and sustainability aren't just PR, they are the foundational trends for survival. Practical recap. Supply managers must track biophysical and ethical impacts. IT integration is a phased journey. And senior leadership commitment is the linchpin.
Absolutely.
Critical thinking challenge. Which of the 5 phases of IT integration is your organization currently in, and what's the barrier to the next phase? And how can a company practically enforce environmental standards on a Tier 3 supplier in a different country?
Complex, real-world problems.
Which brings us full circle to Chapter 12, Future Trends in Supply Chain, the big idea. The future belongs to non-zero supply chains that prioritize ecosystem cooperation, structural flexibility, and social responsibility over isolated zero-sum cost-cutting.
Right. Quoting Tom Linton from the text, it means moving away from zero-sum games where a buyer's win is a supplier's loss. It's about creating new value for the whole ecosystem.
Okay, let's unpack this. What does a non-zero negotiation look like?
Instead of fighting over the price of a component, we co-design a new one that's easier to manufacture and fits my product better. We both increase our margins.
The pie gets bigger. And this is mandatory because of shifting centers of gravity. Demographics are changing where products are made and sold,
Sparking the debate between offshore and nearshore manufacturing, plus the multi-channel retail revolution.
but with all this collaboration, don't companies lose their competitive edge?
This raises an important question. Structural flexibility is the new competitive edge. The ability to pivot during disruptions matters infinitely more than squeezing a supplier for a 2-cent discount.
Because if your rigid supply chain snaps, you have zero product to sell.
Exactly. Resilience is the ultimate advantage.
Practical recap. Stop treating supplier negotiations as a zero-sum game. Prepare for shifting global demographics by building structural flexibility into your network. And corporate social responsibility is no longer an option. It is a mandate.
Total paradigm shift.
Critical thinking challenge. How can your organization shift a current zero-sum supplier relationship into a non-zero collaboration? And if the global center of economic gravity shifts over the next 10 years, how must your logistics network adapt?
These are the questions that define the future.
I want to thank you, the listener, for joining this extensive deep dive into the architecture of modern commerce. You are now armed with the frameworks to view the physical world differently.
And I'll just add that supply chain professionals have an immense responsibility to balance efficiency with environmental and ethical stewardship. They are the architects of the physical world.
Beautifully said. I'll leave you with a final provocative thought to mull over. If modern business warfare is no longer company versus company, but supply chain versus supply chain, is your organization's biggest threat a rival brand or an unseen, unmeasured inefficiency hiding deep within your own network?